Hello boys, what is up? Hope you are doing well by the grace of Almighty Allah. Okay, today here we are with another problem solving tutorial of trigonometry from a textbook of exercise 9.1. Today we're gonna solve problem 15, 17, 21 and 23 from your textbook. So to enjoy the video and to get the video tutorial to solve your problem, stay with us till the end. Okay, let's see. So our first problem is problem number 15 of today's lecture. So look at the destination. As I mentioned in the earlier tutorial or in the last tutorial, that you just need to look into the destination and we'll move through the destination. So here our destination is 2 cosec. Okay, from the given one we just can take LCM. Okay, taking LCM, what are you going to have? Sin square a plus 1 minus cos a whole square. Okay, it's just a normal procedure LCM. Okay, let's see what's going to happen next. So look, in the third line we write down 1 minus cos square a instead of sin square a. How? Look, we know sin square a plus cos square a is equals to 1. So if we change the side, sin square a is equals to 1 minus cos square a. Just the transposition law. Okay, now plus 1 minus cos square as it is, another denominator we have the same thing. Now if we're going to apply the formula of a square minus b square, what are you going to have? Look, 1 minus cos square. 1 minus cos square can be written as 1 square minus cos square. So a square minus b square, we can write 1 plus cos a into 1 minus cos a, and plus 1 minus cos a whole square remains as it is, divided by the denominator remains as it is. Okay, now we're going to take common. What are you going to take common? Okay, let's move to see. Look, in the numerator we take common 1 minus cos a in the numerator from the both expressions. So what are you going to have? If we take common 1 minus cos a from the first expression, inside the second bracket we have 1 plus cos a, plus for the plus sign before the second expression, and from 1 minus cos a whole square we take common 1 minus cos a. So there will remain another thing, and the thing is 1 minus cos a. Okay, so look, from the numerator and denominator we have a similar term, and the term is 1 minus cos a. So we can omit each other, and by omitting each other we're going to have a new loop. So look, by omitting the similar term from numerator and denominator, we have a look like this. Inside the second bracket, if we omit the second bracket, we have 1 plus cos a plus 1 minus cos a. So look, plus cos a on the numerator, plus cos a and minus cos a omit each other. So by omitting each other we're going to have a form 2 on the numerator, 1 plus 1 becomes 2 by sin a. So 2 by sin a can be written as 2 into 1 by sin a. And look at our destination, 2 remains as it is, 1 by sin a is equals to cosec a, as you know from the hexagon. Okay, so here we reached into our destination. Okay, so let's move into the next problem. This time we're going to solve problem 17, inshallah. So look at the question. Here our destination is 1 plus sin a by 1 plus sin theta by 1 minus sin theta. So look, to making similarity with the destination, we're going to apply the formula what? Tan theta is equals to sin theta by cos theta, plus instead of sec theta we know the inverse of sec theta is equals to 1 by is cos theta, so we write down 1 by cos theta instead of sec theta. Now we're going to take LCM inside the bracket. Okay, so let's see. Look, taking the LCM inside the bracket, what are you going to have? We're going to have 1 plus sin theta divided by cos theta. Now by splitting, we just write down the square by splitting individually to the numerator and denominator, and we write down 1 plus sin theta whole square divided by cos square theta. Look, if we have a fraction like a by b whole square, we can write it down by omitting the bracket, a square divided by b square individually. So it's not a big deal. So rather, just let's move what's going to happen next. So look here, on the very next line our numerator remains as it is, 1 plus sin theta whole square that we wrote down in the previous line, but instead of cos square theta in the denominator we write down 1 minus sine square theta. How? By the side note. Because sine square theta plus cos square theta is equals to 1. Therefore, cos square theta is equals to 1 minus sine square theta by the transposition law. Now, by splitting the numerator, we write down 1 plus sine theta into 1 plus sine theta. How? If we have a square, we can write down a into a. But here we have 1 plus sine theta whole square. That is why we can write down 1 plus sine theta into 1 plus sine theta. And on the denominator, 1 minus sine square theta, we can apply formula of a square minus b square, because 1 has a square of it itself. So we're gonna have, by applying formula of a square minus b square on the denominator, we have 1 plus sine theta by 1 minus sine theta. Now look, from the denominator and numerator we have a similar term, and the term is 1 plus sine theta. So they omit each other. Now look here. Look at the destination. What do you have? 1 plus sine theta by 1 minus sine theta, and our destination is matched. So our math is done. So moving to the next one. Okay, this time we're gonna solve question number 21. So look what we are given. We are given cos A plus sin is equals to root 2 into cos A. Look carefully here, the roots is only over 2, not over cos A. So it's root 2 into cos A, not root 2 cos A. Root 2 cos A means the root is above the whole thing, but no, the root is only over 2. Okay, our destination is cos A minus sin A is equals to root 2 sin A. Look, in the given question we have root 2 with cos A, but in our destination we need root 2 with sin A. Okay, so look, that means for doing so we need to keep sine apart from cos A. So look, we write down sine alone and the cosine term or cos A together. So by writing them, what are you gonna have? We're gonna have sine is equals to root 2 into cos A minus cos A. Now we're gonna take common cos A, and what are you gonna have? By taking common cos A on the right side, look, we have sin A is equals to, if we take common cos A, from the first expression we have root 2, and from the second one there is a minus and minus, and from the second one we have minus 1. So look, sin A is equals to root 2 minus 1 into cos A. Still we have root 2 with cos A, but we need root 2 with sin A in multiplication form. That is why we need to introduce root 2 on the left hand side. How? Okay, let's see on the next line. Look, when this kind of cases arise, that we have root 2 minus 1 or root 2 plus 1 or root 3 plus root 2, whatever it is, these are known as, we just gonna multiply them by their simple conjugate. Conjugate means we just multiply with the same thing, just change the sign. That means if there is minus sign, we just change the sign, we just take it as plus. If the given sign is plus, then we just multiply with minus. Look, we have root 2 minus 1 into cos A. So we just gonna multiply both of them with root 2 plus 1. Here root 2 minus 1 and root 2 plus 1 are simple conjugate to each other. So multiplying both sides with root 2 plus 1, what are you gonna have? On the left side we're gonna have sin A into root 2 plus 1, and on the right side root 2 minus 1 into root 2 plus 1 into cos A. But look, root 2 minus 1 into root 2 plus 1, here we can apply formula. Okay, let's see how to apply formula. Look, by applying formula on the next line, look, first on the left hand side we just omit the bracket by the distributive law of multiplication. So we multiply sin A with root 2 plus 1. So what are you gonna have? Root 2 into sin A. When you're gonna multiply sin A with root 2, and when sin A gonna multiply with 1, we just gonna get sin A is equals to, on the right hand side we apply the formula of a square minus b square, backward formula. So a minus b into a plus b becomes a square minus b square. B square means 1 square, so it's 1. So look, square root sign and root 2 square, right? So square root sign and square sign omit each other. So what are you gonna have? We have only 2, that we can see on the very next line. So on the very next line on the right side we're gonna have 2 minus 1 into cos A. Now finally root 2 sin A, root 2 sine on the left hand side, root 2 sine on the left hand side is equals to, look, on the right hand side 2 minus 1, 2 minus 1 means 1, so 1 into cos A, and we shift sine A on the right hand side, so sine before the left hand side, sine before the sine A on the left hand side is plus, so when you're gonna shift it on the right side, the sign becomes minus according to the transposition law. So why do we shift it? We have shifted it because look at the destination, we need root 2 sine A alone, that is why we keep root 2 sine A alone and shift the others on some other sides. Okay, so let's see what's going to happen on the next line. So 1 into cos A means cos A, therefore cos A minus sine A, we just write down the right hand side on the left hand side, 1 minus cos A minus sine A is equal to, and left hand side on the right hand side, root 2 sine A. So look at the question, what is our destination? We are asked to prove that cos A minus sine A is equals to root 2 sine A. So here we are, our problem is done. Okay, this time we're gonna solve problem number 23. So what we're given? We're given cosec A minus cot A is equals to 4 by 3, and we're asked to find cosec A plus cot A. This is just like the previous problem that is solved. That means this is just like the problem number 21. Okay, so look, what is our destination? Our destination is cosec A plus cot A. Only the difference is in 21 we are asked to prove, and here we just need to find. So by given cosec A minus cot A is equals to 4 by 3, so as we need cosec A plus cot A, we're going to multiply both sides with cosec A plus cot A, that we can see in the screen with golden color. So we can have in this form cosec A minus cot A into cosec A plus cot A divided by 4 by 3 is equals to 4 by 3 into cosec A plus cot A. So we can apply formula on the left hand side. So which formula? We're gonna show it on the next line. So look, by applying formula A cosec A minus cot A into cosec A plus cot A, that means A minus B into A plus B, that means A square minus B square. There we have cosec A square A minus cot A square A is equals to the right hand side remain as it is. Okay, now we know another formula, cosec A square A minus cot A square A is equals to 1. That is why instead of that on the left hand side we write down 1 is equals to right hand side remain as it is. Okay, now what is our destination? Our destination is cosec A plus cot A. So we'll keep cosec A plus cos A on the same in a single side and the remaining on some other side. So let's see what's gonna happen. So look, if we're gonna cross multiply, so 4 by 3 will be shifted. So if 4 by 3 will be shifted on the left side, what are you gonna have? Here they will be changed their position, that means the numerator becomes denominator, denominator becomes numerator. So 1 into 3 becomes 3 divided by 4. So we're gonna have 3 by 4, and on the right hand side cosec A plus cot A. We just skip this line, rather we write down directly, therefore cosec A plus cot A is equals to 3 by 4. Look at the destination, we are asked to find cosec A plus cot A, and here we have on the screen cosec A plus cot A, and the result is 3 by 4. So this is end for today. Hope you enjoy the video. Okay, we're gonna come with another problem solving tutorial from your textbook, inshallah. Till then, stay with us, stay safe, stay home until the further decision or declaration of government. Allah Hafiz.